Hi everyone, my name is Leonie Reins and today we're going to look at one of the central challenges of energy law: how to regulate technology during the energy transition. The energy transition is technologically driven, but law does not evolve at the same speed as technology. This creates the pacing problem. Our first learning objective today is to understand the pacing problem and the Coleridge dilemma. The second objective is applying different regulatory strategies to address these challenges. Let's look at the pacing problem. The basic idea is simple. Technology evolves faster than regulation. And because of that, new technologies often don't fit into existing legal categories. For example, is hydrogen treated like gas? Is battery storage considered generation or infrastructure? Are energy communities consumers or producers? And most importantly, new technologies create risks that the existing rules were not designed for. The graph on the slide shows this visually. Technological change accelerates steeply over time, while legal change moves much more slowly. The widening gap between those two curves is the pacing problem. And this gap is especially visible in the energy sector, because the energy transition is so strongly driven by innovation and new technologies. This brings us to a classic dilemma in technology regulation, the Coleridge dilemma. It highlights two problems that occur at different stages of technological development. First, the information problem. In the early stages of technology, we have low knowledge about but high control. We could still shape or restrict the technology, but we don't yet fully understand its impacts or risks. Second, the power problem. Once a technology becomes mature, think of fossil fuels infrastructure, we have high knowledge but very limited control. By that point, the infrastructure, the markets, and the political interests around it are deeply entrenched, which makes change extremely difficult and slow. So the key question becomes, when should regulation intervene? If we intervene too early, we risk acting on incomplete or conflicting information. If we intervene too late, the technology may already be locked into society, making minimal change much harder. The ideal intervention window lies somewhere in between, right here. When we have enough knowledge to act, but before the technology becomes locked in. Energy law has historically struggled with this. Fossil fuels expanded long before we fully understand their climate impacts, and now structural change is far more challenging. So how do we respond to the pacing problem? This slide shows 5 strategies that can help make regulation more flexible, more adaptive, and ultimately better for fast-moving technological developments. Adaptive governance is about designing regulation that can evolve alongside technology and markets. Instead of setting strict one-off rules, we create frameworks that allow for revision, monitoring, and learning over time. This approach is especially useful in the early stages of innovation, when uncertainty is high and impacts are still unknown. For example, regulatory sandboxes for hydrogen or smart grid pilots, or pilot projects that include review clauses. The basic idea here is learning by doing. Soft law refers to non-binding tools like guidelines, recommendation, and voluntary standards. They can be adapted and revised very quickly. This makes them useful in the very early stages of innovation, when formal legislation would simply be too slow. Examples include industry codes of conduct or technical standards. Soft law can increase speed but introduces legal certainty. It is also more vulnerable to regulatory capture and harder to enforce, which makes accountability an issue. So soft law gives us speed and flexibility, but at the cost of legal certainty. Principle-based regulation relies on broad legal principles rather than detailed technical rules. Instead of regulating each technology separately, we regulate according to overarching objectives. These objectives could be sustainability, safety, non-discrimination, or technological neutrality. The advantage is that this approach is very flexible and keeps up with the fast-moving technologies. The challenge is that broad principles leave much more room for interpretation, which can make enforcement and compliance more difficult. Sometimes the problem isn't in the rules themselves, but in the institutions applying them. Existing institutional structures can be too slow, too fragmented, or too siloed to deal with fast-moving technologies. Institutional reform can mean creating new agencies, improving coordination between energy, climate, competition, and other authorities, or introducing early warning functions. The final strategy is the incremental approach. Instead of one large legal reform, regulation evolves step by step. This is useful when social resistance is high or when the economic impacts are still uncertain. It allows the law to evolve alongside scientific evidence. As knowledge improves, the rules can be adjusted. Examples include gradual increases in carbon pricing, the stepwise inclusion of new sectors into the emissions trading system, or phased renewable energy targets. To summarize, we looked at the pacing problem, which is the structural gap between how fast technology evolves and how slow regulation adapts. We then examined the information and the power problem, also known as the Coleridge dilemma. The difficulty of intervening at the right moment, when we know enough to act, but before technology becomes locked in. And finally, we discussed 5 strategies to make regulation more adaptive and responsive. The key takeaway is, energy law has to regulate technologies that evolve faster than the law itself. The challenge is not to regulate more, but to regulate smarter.